Welcome to Maths for All. I'm Aisling Flynn. This is exam practice. In this video we have a question from paper 2 in 2016. It's from section B and it's worth 55 marks and it's on areas and volumes. Okay, so let's have a read of question 7. The Atomium in Brussels is one of Belgium's most famous landmarks. It consists of 9 identical spheres joined by 2 types of cylindrical pipes. Part A, the atomium is modelled on an iron atom that has been magnified 165 billion times. Given that a billion is 1,000 million, write 165 billion in the form of A times 10 to the power of n, where n is an element of the integers and 1 is less than or equal to a is less than or equal to 10. Okay, so this is a question not in areas and volumes but on standard notation. Okay, so let's write down firstly, I think, what a billion is in digits. Okay, so a billion, we're told, is 1,000 million. So a million is a 1 and 6 zeros. Okay, a billion, we're told, is 1,000 of those, so we would have to add another 3 zeros. Okay, so we have 9 zeros. And we have 165 billion. So we'll have 165 and 9 zeros. Okay, just the use of the comma here in our textbooks, etc. In Ireland we use comma to separate hundreds, thousands, millions and billions as shown. Just be aware, if you learned your maths in another country, sometimes commas are used as we use decimal points, so just be familiar with that. Okay, so how do we write that in standard notation? We need to move our decimal point, which is currently at the end of the number. Okay, and we don't really write it when it's at the end of the number. We have to move it so that we arrive at some number a that is between 1 and 10. Okay, so let's move it. 1, and we count how many spaces we moved it at the same time. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I'm going to leave it here between the 1 and the 6. Okay, and I moved 11 spaces. All right. Why between the 1 and the 6? Because that will give me a 1.65. That's a number between 1 and 10. That's now my A. And of course we have a much bigger number than 1.65. How many bigger times bigger? Well, we'd have to multiply that 1.65 by the number 10 11 times. Okay, so that's my answer. Did we get it right? Okay, yes, we did. Now ours looks very different to that. It doesn't matter how you arrive at the answer. 11. Okay, as long as you do. Let's check the marking scheme for that. 15 marks were given to that. That's a lot. Okay, there was opportunity to get 4 marks partial credit. Okay, which isn't a huge proportion of the 15, but you can see if you wrote any of these down at all on your page, you'd get 4 out of 15. Okay, so have a go is the advice. Now on to areas and volumes properly. Part B, the diameter of each sphere in the atomium is 18 meters. Find the radius of each sphere. So we're asked for radius and we're given the diameter, okay, which is 18 meters. So you should know that a diameter is the distance through the center from side to side, the full distance, and the radius is half of that from the center out. So the radius is half a diameter. So our radius will be 18 meters divided by 2, which is 9 meters. Okay, And following from that, part 2, find the volume of each sphere corrected to decimal places. So at this stage you're going to need a formula. So anything that's circular or spherical in shape, you need to go to your formula book. So let's find the formula for the volume of a sphere. Okay, so you'll be going to this page in your formula books, which you'll get really familiar with. Okay, and you look for the shape in question. We're looking at spheres. Okay, so make sure you have sphere and not a circle or disc. And we're looking for volume, so choose V for volume. And we'll copy that onto our question. Okay, so let's transcribe our formula. Always write that down. 4 over 3, that's 4 divided by 3, multiplied by pi, multiplied by r cubed. Okay, so let's fill in the information and calculate. Okay, so V equals 4 multiplied by pi. Now pi, we're asked for our answer in 2 decimal places, so we'll give pi in decimal form, 3.14. Okay, multiply by our radius, which from part 1 is 9 cubed. Okay, what is cubed? It's 9 cubed will be 9 times 9 times 9. Okay, and all of that at the end, well, we can divide first or later, doesn't matter. We'll divide all of that by 3 at the end. Okay, now you can do this all at once on your calculator or step by step. We'll just do it step by step to make sure you're on track. So the top line, 3 times 3.14 multiplied by 9 cubed. So you can use the cube function, or you can do 9 times 9 times 9. And the top line comes to 9156.24, and we have yet to use that dividing 3. Okay, so divide that answer by 3. And I get 3052.08. Okay, and it's volume, so it's meters cubed, so it's 3D shape, meters cubed. In maths you won't lose marks if you forget to include the units. Okay, let's check, did we get it right from the marking scheme? Okay, our radius was 9. Okay, that's an easy 5 marks. Okay, if partial credit of 1 if you wrote that you should divide or similar. Okay, and your volume calculation was another 5 marks. Okay, you can gain 1 mark or 2 mark. Along the way you get 1 mark if you wrote down the correct formula, so always write down the correct formula. Okay, or if you wrote down your radius, your correct radius, you get 1 mark. You get 2 marks if you put the right numbers in the right place, as in here. Okay, you get 2 marks. If you made a mistake, you would get 2 marks. Okay, note their answer looks slightly different to ours. It depends on what you use as your value of pi. So this is what we got, so we would get 5 out of 5. Now, part C, find the combined surface area of all 9 spheres in the atomium correct to the nearest meter squared. Okay, so what are we being asked for here? Find the combined surface area of 9 spheres in the atomium correct to the nearest meter squared. Okay, all right, so again, area of a sphere, we have to refer to our formula book. Okay, so on these pages, look here, in the following, A represents the curved surface area. Okay, so we're looking for A and we're looking for it for a sphere, so this is the formula we should select. Okay, so we've seen in the previous part that you get marks for writing down the correct formulas. Let's do that firstly. A equals 4 pi r squared. Okay, and that's for the surface area of a sphere. let's fill in our numbers. So 4 multiplied by pi, 3.14, multiplied by the radius, which is 9, squared. So that's 9 times 9. Okay, and let's calculate that. 4 times 3.14 by 9 squared is 1017.36. Okay, now we might forget and think we're finished there, but we have 9 spheres, so we'll need to multiply that by 9. 1017.36 multiplied by 9, and so I get 9,156.24 is the answer, but we're asked to give it correct to the nearest meter squared, which is the nearest whole number. 0.24 is less than halfway, so we'll give our answer as 9156 meters squared. Okay, let's check our marking scheme. Okay, again our answer looks slightly different to the marking scheme due to the value of pi we used, so it's fine, we weren't told exactly which value to use. Okay, and there are 5 marks going for part C, and again you see that you get a mark for identifying the correct formula, so always write down your formula, or if you put in your radius correctly you get 1 mark, or if you indicated that you should multiply by 9 you get 1 mark. If you substitute fully correctly you get 2, but if you don't finish, or if you stopped at 1 sphere and didn't multiply by 9 you get 2 out of 5. Okay, let's go to the next part. Each of the 8 cylindrical pipes extending from the center sphere has a radius of 1.65 meters and a length of 23 meters. Find the sum of the curved surface area of all 8 pipes correct to the nearest meter squared. So there's a bit of information there. Firstly, we've got 8 of them, so at some stage we'll have to multiply by 8. And next we're dealing with cylindrical pipes, so we're looking at cylinders. They have a radius of 1.65 meters and a length, length of 23 meters. So if it helps, sketch. Alright, it may or may not. Right, so we've got cylindrical pipes. Now the length may also be referred to for cylinders as the height h, and we've got the radius here. Okay, so we're looking for curved surface area of the 8 pipes. We will need a formula. Okay, so refer once more to your formula and tables books. Alright, so we're looking for the cylinder, which is here, and we're looking for curved surface area, which is the letter A, and that's given here. Okay, so this formula gives the area of the curved surface area, which is the sides of the cylinder. Okay, or as when I'm teaching this I talk about a tin of beans, it gives the area of the label around the sides, so not the top and the bottom. Okay, but that's all we need in this question. Okay, so once more we'll begin by writing down our formula. A equals 2 pi or h in this case. Okay, and the next step then is to substitute correctly. So 2 multiplied by pi, 3.14, multiplied by r, so radius in our question is 1.65, multiplied by h, which is the height, but it's referred to as length, so 23. Okay, and calculate that. Use your calculator. 1.65 pi, 1.65 times 23. Okay, so for one cylinder I get 238.326. Now always go back and read the question, make sure you've answered what we're asked. We're asked to find the sum of the curved areas of all 8 pipes. Okay, so we're not finished yet. We have to take that value for one pipe and multiply by 8. Okay, so times 8, and we get 1906.608, and we're asked to give to the nearest meter squared. So 0.6 is more than halfway, so the answer I'm going to give is 1907 meters squared. Okay, let's check our marking scheme. All right, so we got it correct, more or less, because we used 3.14. Okay, we got 1907. Okay, there's 5 marks going for that. Again, you'll get 1 mark if you get the correct, write down the correct formula. Okay, and you'll get 2 out of 5 if you put the right numbers in the right place. Okay, and then 5 out of 5 for getting it correct fully. Right, another part. The other 12 cylindrical pipes connect the outer spheres to each other. Each pipe has a radius of 1.45 meters. All 12 pipes are equal in length. The sum of the curved surface areas of the 12 pipes is 3,170 meters squared. Find the length of one pipe. Give your answer correct to the nearest meter. Okay, so we're asked to find the length. We're talking about curved surface areas, and we've a whole heap of information in there. Okay, so this is a working back type question, but we are dealing with curved surface areas of cylinders. So I would write that formula down first. A equals 2 pi r h. Okay, and in this case we are told that the answer is, for all 12 pipes, 3,170. So we will have the answer for the area, but we have to work backwards to find the length of one pipe. Okay, now so if we take 2 pi r h, that's the surface area of one cylinder, and we're told that we have 12 of them, so 12 times 2 pi r h should give the answer of 3170. Okay, so there's an equation. If you have an equation, you can solve for an unknown. What we're going to do is, on the right hand side here, we're going to put in all the information we have and work out as much as we can. Okay, so 12 times 2 is 24. Pi we can replace with 3.14. Radius we can replace with 1.45 from the question. And the only thing we don't know is the height, which can also be called the length. Okay, so that's what we're trying to find, and that should be equal to 3170. Okay, so the next step will be to simplify. Let's multiply all those numbers on the left. 24 multiplied by 3.14 multiplied by 1.45 gives me 109.272 h equals to 3170. Now how do you solve for h? If you want just one h, you will divide by whatever's beside it on both sides. So here your algebra skills coming into use once again. Okay, so divide on the left, division will give you 1h, and on the right we will get 29.01 and lots of digits meters. Okay, and we're asked to give our answer correct to the nearest meter. So I'm going to say the length of the pipes equals 29 meters. Let's check our marking scheme. So yay, we got 29. Okay, very good. Let's look at what we did. Okay, they worked backwards and they found one cylinder first. It's all equal. You get 15 marks for getting it fully correct. If you use your 12, you get 3 marks. If you wrote down the correct formula, you would and just that, you would get 3 marks. If you mentioned the radius, you get 3 marks. If you put all the right numbers in the right place, but didn't finish calculating, you would get 5 out of 15 here. Okay, so always start it and give it a go. Okay, so part 3, the curved surfaces of the 20 pipes, that was 8 plus 12, and the 9 spheres are covered in stainless steel. Stainless steel costs €70 per square meter. Use the areas you've calculated or have been given above to find the approximate costs of the stainless steel required to resurface the atomium. Okay, so we have to get our answers from before. So we have our spheres, and we calculated those to have a surface area of 9156. We have our 8 inner pipes, and they had an area of 1907, and we had our 12 outer pipes, and we were told or given in the previous question that their surface area was 3170. So the first thing we should do is add those to get a total surface area. So 9156 plus 1907 plus 3170 gives me a grand total of 14,233 square meters. Okay, and we're told in the question that stainless steel costs €70 per square meter. So to get the cost, we should multiply this value by 70. Okay, so times 70, and I get a whopping €996,310. Okay, let's check our marking. Did we get it right? Okay, we had slightly different values for some of those surface areas, so our total would be slightly different, but that's all good. You'll still get your full 5 marks. And that's that full question.